Hey everyone, thank you so much for joining the second episode of our Masterclass series. Well, I'll tell you how to build an IoT based real time attendance system for your Slack channels. I'm Srushtika Neelakantam and I work as a developer advocate for Ably Realtime. You can reach out to me via Twitter at Srushtika or email me at devrel@ably.io. You can ask me any questions that about the project that I cover in today's masterclass or anything that I covered in the previous masterclass. If you have any suggestions for any topics that you want me to cover in the future masterclasses, feel free to drop me a line and I'll be sure to get back to you. Right, so what exactly will we build in today's masterclass? We'll begin with an IoT board. In this case, I'm using an Adafruit Feather Haza ESP8266. This is a computer in itself and has the Wi-Fi component inbuilt, so it can communicate over the internet with any other entities that are involved in this project, as you'll see further on. We'll also use an RFID reader, which is the MFRC 522 component, and I'll also give you links about where to find out more about these boards as we progress through the masterclass. But we'll attach these two components together and make the RFID reader read an access card. After it has read that card, it'll tell that information to the Adafruit Feather Haza ESP8266 board, which will then communicate that information via the MQTT protocol to the Ably MQTT broker. Ably MQTT broker will then in turn publish this message to Zapier, which you can have a lot of really cool workflows. Say when this happens in this application, I want you to do this in this other application. So you can connect any of the different applications. Hundreds of them are available in the Zapier store. You can do this using webhooks, which is essentially a REST request. I'll talk more about that as well as we progress in the masterclass. And finally, Zapier will in turn publish that message again via webhooks or REST to a Slack channel. Now, there's a lot of tech jargon involved here. I've talked about a broker, MQTT, webhooks, blah, blah, blah. Don't worry, because I cover all of these concepts in this masterclass. A couple of things to note before we begin. This is not a follow-along masterclass. I'm not really expecting you to build this app along with me as I'm talking to you live. But what I will do instead is talk to you and explain to you everything, the concepts that are involved, and I'll tell you the wiring and the different components, how to connect them together. I'll show that to you as well. I'll finish this with a live demo as well. So you can check all of this back at your leisure because the recording of this masterclass will be shared with you. And along with it will also be a written version tutorial. So you can follow along in any way you like. But this is mostly about understanding the concepts and clearing any questions you might have following those explanations. So what our agenda is going to be for this masterclass is we'll begin with understanding a bit more about what Ably is relevant to be used as a broker in this particular project. We'll also understand a bit more in detail about the working of MQTT as a protocol and understand why it is, IoT and MQTT generally go hand in hand. Why is that a case? We'll understand that. And then we'll look at the things you need because it is an IoT project. There are a lot of, hardware components and software components that you will need. So I'll just, hand out a list of things that are necessary for this project to work and also link you to the places where you can get these components. We'll then look at how to wire up these different IoT components together so they can work in conjunction with each other and then publish messages to the Ably MQTT broker. We'll understand the code for doing that as well. I said understand because a lot of the MQTT libraries or IoT libraries that you work with come with a lot of example codes. And more often than not, you end up, editing some of those example applications instead of writing everything from scratch. So I thought it would be a better use of time if I just, walked you through the code that I've written to make this application work instead of writing everything from scratch. So that's what I'm going to do. That will be the first part of the application where we'll make our IoT device communicate with the Ably broker. Once that's all set up and we've checked that it's all working as expected, we'll then understand the working of webhooks because that is the second part of the that will enable Ably to invoke that Zap or send a message to Zapier whenever this IoT device is publishing a message to Ably. After all this is set up, we'll also see in the Zap how to connect it to the Slack channel that we are interested to send a message to. After all this is set up, we'll look at the live demo of this whole application, the working of it, and see how beautifully the IoT device can send a message to a Slack channel with minimal effort. At the end, we'll take a look at the Ably Hub, which is a repository of open data sources. And it is actually really relevant to the kind of IoT applications that we'll work with today. And I'll tell you why it is more relevant and the different really cool ways you can use it for your IoT applications as well. And we'll end this whole masterclass with a live Q&A. I'm really excited to learn more about your questions, so keep them ready as we move on, and I'll get to that at the end. Let's get started then. So let me begin by telling you a bit more about Ably. Ably offers real-time messaging APIs for your event-driven applications, or essentially to make your applications event-driven. What I mean by that is if you have any two clients that are interested in communicating over the internet in a real-time or a live sort of fashion with latency of the order of a few milliseconds, then Ably enables that sort of communication between those two clients or any number of clients, maybe millions of clients. So just to make you understand a bit better, let's consider this application that you see on the screen, right? So this is a logistics application where the truck is moving along doing deliveries. It also has a GPS tracker that is tracking its location and constantly publishing that information on the internet. What it would do is simply publish that information to Ably, and Ably in turn will publish that information to all of the interested parties. Now, publishing is a push mechanism rather than a pull sort of mechanism that you see generally in HTTP-based communication. So all of this communication happens through a pub sub or a publish subscribe messaging pattern. And the data that is flowing through an application is also distributed in different units called channels. For instance, in location channel, it only contains location data, and only the clients that are interested in that data would be participants of that channel. And similarly, the job updates channel, only the app server and the truck are interested in that particular data, so they are part of that channel only. And the customer desktop will have no access to the data that is flowing through the job updates channel. So you have a lot of permissioning and privacy as well, as your application needs. So because it is a distributed systems network that provides it all scalability, protocol interoperability, and everything that you may require for your real-time application is already given out of the box by Ably, so you don't have to build this complex infrastructure from scratch. We'll see how we use this distributed real-time infrastructure for our MQTT work today. But before that, let's understand a bit more about what MQTT itself is. Now, MQTT is a lightweight, very lightweight, and bandwidth and battery efficient protocol. And this exactly is the reason why it is really suitable to be used with IoT devices, because they're bandwidth and battery efficient, right? They're limited in terms of their bandwidth. So this also works in terms of a publish and subscribe mechanism where data, unlike in REST, is pushed to the clients that have subscribed to that topic or channel. In MQTT, you call the different channels of data as topics and not exactly channels, but they both refer to the same concept. So it's up to you what you want to call it. So whenever some data is published, all of the subscribers that have already subscribed to that topic or channel would receive that data instantly. Now, one thing to note is, unlike some other real-time protocols such as WebSockets, MQTT is not exactly a point-to-point protocol, which means this IoT board cannot directly publish something to this particular device. It definitely needs some sort of a middleman that will do the routing of the message from the publisher to any of the rightful subscribers. And in this case, we'll use Ably as that middleman, and that middleman is officially called an MQTT broker. So Ably has the capability of being an MQTT broker because it does provide an MQTT endpoint and to which IoT devices can publish data to over the MQTT protocol. As I also mentioned, it provides a lot of protocol translations as well, which means all of these devices or servers or anything else you have as clients that are interested in data, they need not necessarily communicate also in MQTT. They can communicate via SSC or WebSockets, for example, and they don't have to do any of this translation on the client side. Ably will provide that by default. Awesome. Now that we understand what MQTT is and how it works, let's get to our project. The things you'll need to make this project work are there are a couple of hardware things and some software things. Let me tell you all of these one by one. The Adafruit Feather Haza ESP8266 board is our main IoT board. People use Raspberry Pis, Arduinos, etc. This one is an Adafruit Feather, and it is a mini computer in itself that can run a piece of code on it. And this particular variant, which is ESP8266, there is a typo there. It needs to be 8266. This has a Wi-Fi component inbuilt, which we definitely require for our device to communicate over the internet and tell Ably, hey, someone has touched their access card on the RFID reader, so you may want to know. And MFRC522 is the RFID sensor, which will enable which will basically read the access card and send that information to the board, which will in turn communicate that with Ably. And to connect these both together, these components together, you will need some sort of jump wires, things that look a bit like that. I'll tell you a bit more about this whole connection setup that you see. And you may optionally need a breadboard to make these connections more secure. Actually, it is really important that all of these wires and all of these components are connected with each other in as secure way as possible. And the best thing to ensure that is solder all of the jump wires to the different components involved. And that's exactly what I've done. So assuming you have all of those things, the software components that you need to work uh, on this particular project is the Arduino IDE, which is where we'll write the code that we are expecting to run on this Adafruit Feather Haza board. You'll also need an account with Ably, so you can get some credentials to make the Ably MQTT broker work with your project. You'll also need an account with Zapier to set up a Zap and connect with Slack. And if you're wanting to check out the message coming through in a Slack channel, you'll of course need an account with Slack as well. All of these can be free or paid as per however you like them to be. So now that we know the things we need, let's get to the wiring of the IoT components. This is a pretty simple sort of wiring. This particular wiring is only applicable to this particular board, which is a Haza Feather. If you're using any other board, such as the Arduino Uno or a Raspberry Pi, a lot of things on the internet tell you how you can connect this particular component to that particular board. But in our case, these are just the Haza pins. As you can see, you can locate the Haza pins and then connect them to the respective pins on the RFID reader, and your component should be all set up. I have my component set up, as you can see here. I have connected my Feather board um, to a power source, and then I have an RFID reader. All of the wires are soldered, as you see, and they're connected to the respective pin numbers as per this table. So you can come back to this slide when you're looking at the recording and building it yourself, and just pause it, take a look at it, just connect the wires, and that's it. Very simple. Awesome. So assuming at this point in the recording, or when you're actually building it, you've connected it all as required, we'll next understand the code that you need to run on this board to make it all work, make the magic happen. Now, as I said, we'll use the Arduino IDE to write the code that will run on the board. So this IDE is available in two variants. You can use the online editor, or you can use a downloaded software. So I have a downloaded software. I'm going to give it a quick minute to launch while I sip some water. Okie dokie, almost there. So a couple of things on the Arduino software is that each of the files files of code that you write are called sketches, and the syntax of the code that you follow is C++. So you may want to brush that up if you're like me, and university was the last time you wrote C++. So as you see, if you click on File and New, it will open up a new sketch. And every sketch by default, I'm just going to minimize that for now to avoid distraction. But every sketch by default has two methods, which is a setup method, where you set up all of the instructions for your board to work with, for your project to work, for instance, connecting to the Wi-Fi, connecting to the MQTT broker, etc. And then there's the loop method, which runs continuously for as long as the board is connected to your system. So you can constantly check for some changes that are happening in the outside environment and do something based on that in your code, which in our case is continuously check if someone has placed an access card on my reader, and if so, publish a message to Ably, right? Now, a couple of quick things actually to note in the Arduino software is if you go to the tools menu and go to boards manager, this is where you can manage all of the boards that you connect to your Arduino software. So depending on the board you're using, if you're using, let's say, the Haza board that I'm using, or any other board with a Wi-Fi component externally connected, what you need to look for is, once that's done downloading, just search for ESP8266, and it should give you that particular board. And as you can see, Adafruit Feather Haza ESP8266 is part of that, which means when you install this board on your Arduino, it not only is capable of communicating with your board, but also it installs all of the essential libraries that come with it. In this case, there's a Wi-Fi library that lets it connect to Wi-Fi. So all of these essential libraries are already installed with this board. So just select the latest version and install it. I already have it installed, so I'm not going to do it now. Another quick thing here is if you go to the sketch menu, gonna give it a minute. My laptop's acting out as usual in live demo. That's expected. So in the sketch menu, if you say include library and go to manage libraries, that will fire up the library manager that comes by default with the Arduino software. And in the library manager is where you will search for all the libraries that you need in your project. Now, why do we need libraries is, say for the RFID reader, we need the library to be able to use the different methods that come with it. Say, if it's to check if it is reading a card, if it is able to read some info, etc. So for instance, if you see MFRC522, it should give me that particular library. I select the latest version and install it. There's also SPI, which is a serial peripheral interface, and that library you actually require for any components, any external components to work with the board. But with MFRC522, it comes by default along with it, because you obviously can't make it work without the SPI library as well. So like that, you can select and install any of the libraries that you require for the project. We'll take a look at the ones we require in this project in just a second. Before that, one more quick thing I wanted to show you is if you go to File and see Examples, for every library you install, very nicely, you get examples, a lot of examples, default examples that you can literally open up and start running, uploading on your board, to just see if the components that you have, the hardware components, are connected properly and are working as expected before even going into writing your custom code to make your own magical project, right? So definitely check those out for any of the custom libraries that you've installed. Now that we have understood the working and everything of this particular piece of software, let me open up the code for the project right now we are talking about. As you see, I've started by including all of the libraries that I require. The SPI, which is for the board to be able to communicate with any of the external components, which is the RFID component in this case. MFRC522 is the name of my RFID component, so that's the library I've included. ESP8266 Wi-Fi enables my board to connect to Wi-Fi, and that comes inbuilt when you install the board. And MQTT.h is another library I installed, again, using the include library manager method that lets me use the MQTT protocol to communicate with a broker. In this case, that would be Ably. Now, this is these pin numbers are defined as per the diagram that I showed before. So this will be different as per the IoT board you're using. So if you've used a different board, make sure to change this part before moving forward. The next thing we need is to create the MFRC 522 instance. Just pass in the pin numbers, SS pin and RST pin, and that will create an instance that we'll use later on in the code. A couple of things before we move to the setup method is specify your Wi-Fi name and password. This is actually not really my Wi-Fi password name. I just set up an easy one for this masterclass. I actually am known for having secure passwords for my hotspots, So anyway, put the name in for your Wi-Fi, put the password in for your Wi-Fi, so it can use those details to connect to the Wi-Fi. We also have the Wi-Fi client secure class that's coming from this library, and we need that instance to pass it on to the MQTT client to make that connection over MQTT. And the MQTT client is part of the MQTT library, and one of the objects from that class we'll use to perform all of the MQTT functions that we have. Now, before I dive into the next part of the code, let me come back here to the presentation and tell you what exactly will we be doing as part of this code before I go ahead and explaining you every statement. Right. So as I mentioned before, there is definitely always a setup method and a loop method that comes by default with every sketch file that you run on the board. We also have a custom method called connect in this particular project that I'll explain in a bit. In the setup method, we start by setting the data rate, which is the bits per second in which the data needs to flow from the board to the component to any external service. We'll then set up the information to connect to the Wi-Fi. We've already said SSID is this, password is this. We'll just send it to the Wi-Fi, to the object from the Wi-Fi class and say, hey, connect to this particular Wi-Fi with these details. And then we'll also specify the MQTT broker's connection details, in this case, Ably's MQTT connection details, and then call this custom connect methods that I've set up. In the connect method, the only thing we're doing is we're checking if the Wi-Fi is connected. If so, the next step we need to do then is to connect to the MQTT broker. These two are the simple things we're doing in the connect method. After that's done, we then get into the loop method where the RFID reader is constantly checking if someone has placed an access card, and if yes, if someone has placed that access card and if the RFID reader or sensor has read it, get that ID of a card. So all of the access cards would be in the form of a white chip that you would have seen to access your office, or maybe like a key fob or in any way. But all of these RFID readers have a unique identifier attached to them. What we'll do is get that ID, match it with an employee name, and then publish that as a message to the Ably MQTT broker. Now, the only reason why we're doing this matching of the ID with the name here is because on the other side of this application, we want to send this name as a message directly to Slack. So in between all of this, we don't really have any place where we're processing the messages that are being published by IoT. So that is the reason why I'm doing this matching of ID with an employee name on this side, but it is not necessary if you have some sort of like a middle where some sort of a server that is doing some processing on this data before actually invoking the Zapier method to send a message to Slack. Awesome. So let me get back to the code and continue explaining what's happening. So in the setup method, as I said, we'll begin by initializing serial communications. The bit rate I've set is 9600. SPI begin will initialize the SPI or the serial peripheral interface bus. So the board can then communicate with any of the external components involved. MFRC522.pcd init will initialize the MFRC522 component. So now we can start using this object to do any functions on it. The next thing is connect to Wi-Fi by calling the begin method on the Wi-Fi object and pass it the SSID and password that we set up before. Next thing is we set up the MQTT broker. Now what's happening here is, let me get back here and explain to you a bit how this works. If you see the documentation page, MQTT documentation page on Ably, and check out the Ably MQTT adapter, it will give you in a really simple example what needs to be specified in order to make Ably as an MQTT adapter and connect to it. Before doing any of this, definitely make sure you're logged in or signed up for a free account that will give you access to one or more API keys, which is what you'll need to authenticate with Ably or use it as an MQTT broker. So this is the view of the app's dashboard after you've logged in and clicked on one of the applications that come by default or created a new application. So this API key is what we need. Anyway, coming back to the MQTT documentation on Ably, it's asking us to set the host. Let me increase the font a little bit so you can see it clearly. It is asking us to set the host to mqtt.ab.io. Username needs to be the first half of the API key, which, as you can see from here, every API key is divided into two parts. The first half, there's a colon, then there's a second half. And we want the first half to be the username and the second half to be the password when we're using MQTT with Ably. So we do that. We set the keep alive to 30. We set the port to 8883, assuming the communication is secure. If it is insecure, 1883 is the one you need to be using. So all of this information is essentially present in this documentation. And what I'm trying to say is you can come check this documentation out while you're working on it, if in case you're trying to hack things up and build something a bit different to what exactly we're building today. So let me go back. Before that, actually, one more thing is the MQTT library that we are using has a really good documentation on this GitHub repo. So according to the API reference, what it says is if I call the begin method on my client and pass it the domain name, which is mqtt.ably.io, the port number, which is 8883, as we just saw, and the instance to the Wi-Fi component, which is net here, and then set different options, which is keep alive, which is essentially the only option that Ably worries about. There's also clean session and timeout, which are default values. We don't have to worry about it. This will tell our MQTT client, hey, these are the connection details that you need to connect to the MQTT broker, but only but actually connecting to that MQTT broker will be done by the connect method that we'll see in just a bit in the connect method. After that's all specified, we've already started the connection to Wi-Fi. We'll then call the connect method, which is a custom method where we'll wait for the connection to Wi-Fi and then connect to the Ably MQTT broker. As you can see, what I'm trying to do here is I'm checking if the status of the Wi-Fi object is WL connected, which means the Wi-Fi is successfully connected. If not, every second I'm printing a dot in my serial monitor. Now, serial monitor is essentially a logger that I can do by clicking on this. I'll do that after I've uploaded this code on my IoT device, so you can see what's happening. So what I'm doing until then is I'm printing different dots every second the idea behind this is that it appears like a progress bar, right? That it is still trying to connect to Wi-Fi. After that's done, once it's connected to Wi-Fi, I can say that and say, now it's trying to connect to the Ably MQTT broker. And that is where we'll call the connect method on the MQTT client, pass it the client ID, the username, which if you remember, the first half of the API key, and password is the second half of the Ably API key. Now, don't try to steal this API key. Get a account of your own and get the setup of your own, because this is the same API key which you can use to go into the dashboard, go into the dev console, see if the messages are moving forward, etc. I'm going to deprecate this key anyway, so it's not useful at all. And there are 3 million messages and a lot of connections that come with a free account, so you don't actually need to pay anything if you create an account with Ably to get your own API key. So just do that. After that, we just say, hey, this is connected to Ably broker successfully, and now let's go to the loop method. In loop method, it is quite straightforward. What's happening here is, first of all, this loop runs every 1 second, and as per the API reference of this MQTT library I'm using, the loop method needs to be called every time it's inside the loop. So that's basically what we're doing. Then we check if the MFRC reader has read a new card, if some new card is presented to it, and if it is able to read that card, if it is a valid card at all. So we check those two conditions, and if either of them, if that does not happen, then we'll simply return back to the loop and let it run again and again every second until that does happen. Once it does happen, that is, it does detect an access card, then we just print it to the serial monitor and say access card detected, and we simply then match that the UID of the detected card with a UID that you may have for an employee. In this case, because I only have one single access card and I know for a fact what the UID of that card is, and I also know who it belongs to, I'm just going to do that, do a static check for it. But you can have a switch case here, connect it to your database, or do whatever you like. One more quick thing to note here is that the UID is by default available as a char array, as an array of characters. So I'm just using a quick method here, where I'm publishing where I'm converting this to a string so I can easily match it with what I know is my UID and then publish using the MQTT client on a particular topic, which is synonymous, as I mentioned, to a channel in Ably, the data payload called Srushtika, because this is the UID. And if the card that I put, the UID of that card is equal to this one, I just say, hey, Srushtika has placed her access card. She must be in the office now. And then I'm waiting for 5 seconds. Why I'm doing this is because if the loop is running every second, it is possible that you're still holding the access card to the reader and it will just simply republish that data every second. You don't want that. You want to give some time to the user to take the card back. So that is why you're waiting for 5 seconds before starting the loop again, where you're again checking if the MFRC 522 component has read any new access cards. That's basically it. And this is, as I said, just a method that converts byte array to a string. Oh, this was byte array, not a char array, as I mentioned before. So I stand corrected. Right, now that we have this, when you are ready with your sketch, you would want to press the verify method to compile the sketch and see if we have any errors and things like that. And while it is doing that, let me go back here and tell you how to check if what you're publishing from the IoT device is actually coming through to Ably. So I'm going to come back here to the dashboard, and in the dashboard there is a tab called Dev Console, which is a really cool tool that lets you debug applications and see what's happening in your application. So as you can see, all of this is happening. Some clients are connecting, some transports are being open. But what we're interested in here is the channels one, where we can actually attach to a channel and see if some messages are being published to that channel very easily. So the channel, if you remember from the code, the channel that we're publishing to is called Stand Up. So let me get that from there and come back here, put that in and attach to that channel. As you can see, I've attached to that channel. Now, any message, when I touch the access card, if it is successfully publishing the message to Ably, it should come as a log in this particular table. Yeah, I can actually show you if it is working right here as well, but I can just simply publish a dummy message here and that should come up. Now, our message from the IoT board should come up here as well. Right, so it looks like it is all verified and there were no errors. So let me quickly upload this code to the board. So as you can see, I'm holding this board so you can see what's happening, and I can click on the upload button to upload this. It will take some time, a couple of seconds, and it will tell me if it is uploaded the code 100%. So as you can see, it is connecting. I'm going to wait for it until it's 100%, and then I'm going to touch my access card, which is in the form of a key fob, to this RFID reader. I'm waiting after it's done 100%. Almost there. The one thing I kind of dislike when working with IoT setups is that it takes so much time to just upload the code onto the board. Anyway, now this seems done, and I'm going to open the serial monitor so you can see the logs coming up. As you can see, it is connecting to Wi-Fi. You can see those dots. Now it's connected to Wi-Fi and it's connecting to the MQTT broker. Dots coming up. Right, so it's connected to the MQTT broker. Now let me come back here and then try and touch the card. So as you can see, okay, so it has published the message. But hey, what I have published in my code here is Srushtika, but what I see as the data payload here is some sort of an array with numbers that I don't even understand. It kind of looks like, these are ASCII values of the characters that belong to SRUSHTIKA, but that's not exactly what we published. Now, this is because MQTT is a binary protocol, and Ably or MQTT encodes all the messages before it sends it off to the Ably MQTT broker, and which is why you see this message not in its original state but in some sort of an array. So what you can do is, if you come back to decode MQTT messages on the same documentation that I showed you earlier, it will tell you how you can decode messages that come via MQTT on the client side. But hey, if you remember here, we don't really have a client side. We just want to directly send this message over to Zapier using webhooks. So what happens here? Now, one thing I didn't mention so far is the way we will publish the data to Zapier is using a feature of Ably called Reactor. And Reactor is essentially the term used to refer to any of the external integrations, any of the apps that are integrating with Ably and are being invoked on whenever some message is being published on a channel, right? And with Reactor integrations, the decoding part is done by default by Ably, so we don't have to worry about, hey, we don't have a client side, so where we'll do the decoding. So that's all solved. By the way, there seems to be a duplicate message here because maybe the range of the RFID reader is really cool, really good. So when I was showing you the key hub, it must have detected it already. Awesome. So now that we know the first part of the application is working, let me go back to my presentation and tell you where we're at. So we have connected our IoT boards together. We know the wiring. We understand what MQTT is. We've used that protocol to publish the message on the detection of an access card to the Ably MQTT broker. And we have seen that happen successfully. Now, the next thing we need to do is set up a webhooks endpoint on Zapier or from Zapier on Ably and tell Ably to publish a message to Zapier whenever this message from the RFID scanner is being published or RFID reader is being published to Ably. So before that, let's understand, as I promised, I will explain you what webhooks are. Now, webhooks are a really cool feature that are gaining popularity increasingly in the last couple of months or years. And they're a really cool and very simple mechanism that make any application event driven. What I mean by this is, webhooks are essentially under the hood still REST requests, which are based on HTTP. So you're essentially doing just a REST call to an endpoint. But what happens here is that you're given that endpoint beforehand, and unlike a regular REST request or a HTTP request, you're not exactly sending or requesting some data from a server. In this case, the server would be Zapier, right? So the Ably platform is communicating with Zapier. So you're not exactly sending some information to Zapier. Requesting some information to Zapier, but in fact sending some information. In this case, Ably is telling, hey, this access card has been detected and this is the person it belongs to, so you may want to do something with it. And the way it all works is that only if Zapier sets up an API endpoint and gives that URL to Ably to say, hey, call me on this number or at this address if this happens. And that's how this whole thing works. There also, webhooks are also referred to as HTTP push or reverse APIs sometimes, because it is essentially an event-driven mechanism repurposing the same HTTP-based communication, but telling some other external servers that, hey, this event has happened and you may want to know about it. Doesn't really care what response comes back from the server. So it is really risky sometimes if your webhooks are not set up properly, because if it is not sending the data to the recipient as required, no one will know and you will just lose data. So make sure it's all set up properly and tested properly and is working properly. I hope that gives you a quick intro to what webhooks are. Now let's go back to our Ably dashboard and set one up. As I said, this webhooks is part of our Reactor integrations. So you will need to go to the Reactor tab and add a new Reactor rule. So Reactor event is what we're interested in. There's also Reactor queues, which lets you queue up some messages before some servers or other clients can consume those messages. There's also Reactor firehose, which lets you stream of data into other third-party streaming or queuing services. But in this case, what we require is just an event. Just say, hey, this event has happened, and ping an endpoint. So choose that. We don't want a custom webhooks. A Zapier integration is an inbuilt function in the Reactor integration setup in Ably. So let's go ahead and choose that. And as you can see here, what we require is the URL that we need to ping that belongs to Zapier. So let me go back to Zapier. Now, Zapier, after you log in, will look something like this. It is, as I mentioned before, a connector platform that can enable you to create any sort of workflows when you connect this application and say, hey, when this happens in this application, I want you to perform this action in this other application. And then the third application saying, when this happens in these two applications, then publish or add a row in my spreadsheet to tell me that this has happened. So it's a really cool tool with if you explore, there are hundreds of or maybe thousands of applications that you can connect together. What we'll do now is make a Zap that will let you choose the different applications that you want to connect. The first one which we need, which is when this happens, is called WebHooks by Zapier. So let me search it up. It's called WebHooks by Zapier. I would need a trigger event where I would just catch a raw hook, which means I just need the data that is coming from the post request that is being done to this endpoint. When I say continue, Zapier will give me a URL, which is essentially the webhooks endpoint on Zapier that Ably is expected to ping when some message is published. So I come back here, paste that URL. We don't really need any headers. Feel free to add your own if you like something, customize something. I want a single request to be sent. The source is message. So what happens here is I'm telling Ably to ping this endpoint when some message is sent on a particular channel. I don't want presence or channel lifecycle events to be tracked. I'm only interested in messages. Now, channel filter, I don't want this Ably reactor integration to publish a message to Zapier when any message is published across this whole application. I just want it to publish data to Zapier only when the messages are being published to this one particular channel I'm interested in, which is the stand-up channel. So I'll just write it as a filter, so it'll only track this particular channel for messages to be sent to Zapier. We don't want it enveloped because if you keep the enveloped option on, it will also send a bunch of metadata, which is the encoding method and a lot of those things. And we don't want Zapier to get that. We just basically want our data payload, which in this case should be Srushtika. So go ahead and create that. And it will also give you a little button to test the rule. Say run test now. And it's successful. So 0 errors detected, which means it's all set up properly on the Ably side. Now let's go back to Zapier, finish setting this thing up, say continue. It's taking a bit of time. Test and continue. Hopefully this shouldn't take a long time. Sometimes Zapier can be a pain because it doesn't really update quickly and takes a lot of time to test things up, which I think is what's happening right now. Everything fails during a live demo, right? I mean, it's not a live demo if things haven't failed, so I was totally expecting this. Still waiting. While it is still testing it, let me walk you through the next steps that we'll need to do. So what we've done here is that we're catching this raw hook, that is any post request made to that endpoint. We're catching that, getting the data out of that raw HTTP publish or the request, and sending that data to Slack. And in the do this of the next connector app is where we'll add our Slack channel. So let's actually go and do that right now, and then we'll edit it and retest it again. We'll say Slack here. The action we want is send a channel message. Basically, what we're trying to do is most of the Slack organizations have a channel called Stand Up where everyone says, "Hey, I've come in and I'm going to work on this now." And we're just automating this whole process by saying whenever someone has used the access card to enter the building, just automatically send a message on Slack saying, "Hey, this person has arrived into the building and has basically come in." So send a channel message is what we need. Now this is what I want. I have two different Slack organizations. Ably Developers is a Slack organization that I'm wanting to send this message to right now. So I just say continue, customize channel message. Now this is where you'll pick up the channel that you want to send it to. I have stand up, which I'm interested in. Message text, I want to get the actual data payload. So you just choose a custom one saying raw body, which presumably would contain the string Srushtika, and say something like Srushtika has arrived. Maybe not so dramatic. Just say Srushtika is just got in. Okay, and that will apply to any of the employees that get in with their access card once you've set up that logic in your sketch file. Send as a bot, sure. It's a bot name. Maybe I'll write it as attendance bot or attendance something. It's fine. Um, you can customize it as you want, have an icon for your bot, blah, blah, blah. Include a link to Zap. It's a bit clunky. We don't want a link to Zap every time a message is being sent. Don't want any images attached. Don't want to expand links, blah, blah, blah. All this is fine. You can customize it as you require and then just say continue. Before doing this, obviously, the first step was not set up correctly. So let me go back there and retest it. Hopefully, it'll work this time. If not, we'll go back to choosing the app and event and try to set it up from scratch again. Zapier can be a pain sometimes like this, but it is generally incredibly useful with the kind of workflows it provides. All right, so it's not testing it out. So let me actually work it from scratch again, because sometimes you just need to start it from scratch in order to make it work. So I just say that I have this thing here. Let me check if it's the correct URL here. It's correct. Just run another test to tell it's all legit. Come back here, continue, test and review. Maybe it doesn't want to test and continue. I don't know what's happening. Awesome. So they've collected some sample data and that's done. And let's finish setting this up. Test and continue. And as you can see, it has sent a message already saying this message was generated in Ably, blah, blah, blah. And what it will generate is some garbled text because it's just a test, just got in. Hopefully, this should appear as Srushtika just got in when I again put my access card on my IoT device. So come back down, say done editing, turn this app on and unleash the magic. Ta-da-ta, my app is turned on. I come back to Slack here. I'm again raising this RFID sensor and I'm touching this fob with it. When I touch it, the message, which is Srushtika got in, should appear in this Slack channel. So I'm gonna do it right now. Hopefully, is it working? Is it not? Is it coming in? Oh, something happened somewhere. Let me try it one more time. Maybe it's some sort of a loose connection. Oh, look at that. And it just worked. So it says Srushtika just got in. Maybe because it's the first message that after we enable this app, it is a bit lagged, but hey, it worked. So that's essentially what we built our application to be. So if you come back here to the presentation, we've made our IoT device detect a card and then send a message to our Slack channel. So that's pretty cool. Now, as you saw, this Slack channel is called Ably Developers. This is actually a community Slack that you are free to join, by the way. We've only just launched it, so it doesn't really have any community members. So the viewers of this masterclass could be some of the first few people to join in. We're just still building this up, so it would be really cool to have you on board and get some more feedback or get some discussions going on the really cool open source applications or any other things that you're working with using Ably. And you can do that by going to this link, go.ably.io/join dev community. It is a public invite to the Slack channel. Feel free to join. And I'm gonna move to the next part now. Right, now that we've understood how to build this whole attendance system, pretty cool one, let's also see some of the other things that you can use it for, some of the components that we've already built. You could send an SMS or a push notification when a high security file room is accessed by someone, because that's more instant than sending or that's more grabbing the attention of a user than sending a Slack notification. So you can do any of these because Zapier connects to so many other applications. So you can use all of those plethora of applications to do all of the wonderful things. This is just an example. You can also monitor environmental data. So if you have an IoT device that has a temperature sensor and it is checking the temperature all the time, you can constantly, in the loop of your sketch file, stream that data, keep publishing that data via MQTT to an Ably channel and to the Ably MQTT broker and make that available via the hub. What exactly is a hub? I'll just talk about it in a second, but it's really cool. Also, you can do some sort of home automation based on location tracking. The kind of application I had in mind when I put this down was, say, the location of your car is being tracked constantly by an IoT device that you plant in your vehicle, and this information is constantly being published to Ably. Now, what can happen is whenever your vehicle has just got into the main gate of your home, your door can be automatically unlocked by just placing another IoT device there and telling Ably, saying, hey, whenever the location coordinates of the car are blah, 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 just unlock the door so I can just walk in and don't have to deal with the hassle of unlocking the door. So you can do all these sorts of, amazing, cool, really cool applications with IoT over MQTT, with Zapier again, basically a lot of things that are not even listed here. So, in fact, I'm really interested to know what are some of the things that you think are really useful after learning these couple of concepts that I've talked through in this masterclass. So feel free to tweet those ideas to me or just share those things with me, and I'll retweet them definitely and share it with the world what really cool things you're up to. The last thing here that I want to mention is the Ably Zapier integration. This is not exactly available yet, but this is the link to a public invite. What this does is, in our current application, we published a message to the Zapier endpoint from Ably when the message was published on Ably. But this Zapier integration lets you do it the other way around. That is, when something happens in an application that is part of the first part of the Zapier workflow, you can say, hey, when a new row is added to my spreadsheet, I want to send a message to an Ably channel. So that's exactly what you can do with the Zapier integration. Connect some sort of an app and then add Ably as a second part of it, and add an action. I want to send a push notification, or I want to send a regular message on a channel, and then do all sorts of amazing things with that within your Ably app. So I hope that's useful, and this should go live really soon and should be available for the public to use. But until then, you can use this public invite and try that out yourself. Okay, so I told you I will tell you about the Ably Hub, which is a really cool platform. If I come back here, go to Ably Hub. So what Ably Hub is, it's that it is a repository of open streaming sources. So as you see, everything on this page is basically live data. And you have all of these different products, say Ably Stats, BBC News, Bitcoin pricing, Heathrow flights. And what all of these products are doing is basically publishing real-time data, streaming it continuously all the time for you to consume that data and build amazing things by utilizing that data. For instance, with the Heathrow flights product, we have a tutorial that tracks all the flights that come into and go out of Heathrow. Or if you select a source airport and a destination airport, it gives you the live location of a flight and puts it on a map and things like that. So you can build really cool applications with it. And not just consuming the data that's already available. Ably Hub is especially really useful in terms of IoT. If you're working on some IoT projects, is because you can be a producer yourself, producer of data, and put up your product publicly available for people to consume. You can make it available for free, or you can even charge for the data that you publish. If people are interested in it, they'll pay for it to be able to consume that real-time streaming data. Say if I had a temperature sensor that I put up on the top of this building, I continuously stream that data, put that as a product on Ably Hub, and then let people consume it, build amazing things with it. In fact, to show you how wonderful the hub is, there is a very not hacky, very rough examples page that takes a lot of sources from the hub and puts them out here as live data. I say very rough because obviously it could have been presented in a much better way, but this is just to show you how easy it is to spin something up and get started with real-time data. So as you can see, all of this is live data and it is continuously changing. As you can see, the yen pricing of a Bitcoin is continuously changing. It is either reducing, increasing. You have BBC News live stream coming up. You have Hacker News, the new links. When something is published or submitted, you will see it here. You have Transport for London data, all of the trains going through, all the lines, any station, you just choose that station and you'll have the live data coming through, changing all the time. So I hope that's really useful to some of the applications that you're working on. If you have any questions, as always, or any ideas that you want me to give a shout out to, I'm really happy to do that, and I'm very interested to know what you all are up to so far. That's basically what I wanted to cover, and I'm quickly going to get into the QA part before it's too late. So the first question, we already have a couple of questions actually. The first question someone has asked is, I have an Arduino Uno and not the board you are using. Can I make this project work on that as well? Yes, definitely. As I mentioned, I'm using the Adafruit Haza ESP8266 Feather board, which has the Wi-Fi component inbuilt, which is really useful for me because I want the Wi-Fi anyway to be able to communicate over Wi-Fi. If you have Arduino Uno, from my experience, that doesn't really come with a Wi-Fi component inbuilt, but you can actually buy an ESP8266 component separately, connect it to that, so it can then communicate with the internet, and then check out any of the popular resources. I'm sure there's one available to see how you can connect the RFID sensor to that Arduino, and make everything work. It's definitely possible. Right, so I hope I've answered that question. The next one we have is, can we not communicate directly via Slack via webhooks instead of using Zapier as the middleman? Oh, you can definitely do that. So if I go back here on the Reactor tab and try creating the new Reactor event, as you saw, there's also a HTTP, a custom webhooks endpoint. Now, this could be a webhooks endpoint that you have on your custom servers, but also webhooks on some of the applications that are not listed here. So what you would do then is essentially get that webhooks endpoint from the Slack Slack organization provider that you're part of, and then set that up right here in the custom webhook. The only problem you might face with that is because it's not one of the available integrations, there might be some translation of the format of data that is published from Ably to Slack that may be required to be done by you on the client side. But that's basically it. You can still make it possible. I hope I've answered that question as well. We have one more question, time for one more question. Do you have the instructions to build this app in a written format somewhere? Yes, definitely. I have a whole written tutorial with really cool images, links to different resources, which is not published yet, but that I will include as part of the follow-up email that I'll send you after this masterclass, links to everything that you require, instructions on what to do. You may also skip this whole masterclass and simply follow that written tutorial. You will also have access to the entire code that I've used and explained in this masterclass. Hope that answers all of your questions. We have run out of time, unfortunately, for some of the other questions, but I'll be sure to reach back to you via email or via Twitter. You can also ping me on any of those channels if you have any other questions. It has been a delight to speak with you, and thank you all for joining. I'm going to end this masterclass now. Thank you all for joining. Hope you have a great evening. Bye.